Hello, pre-algebra students. Today we are going to talk about the greatest common factor. This is section 4.2. I'd like you to have your 4.1 notes out as well because I may refer back to them. I do want to review one of the things that we did in 4.1, which was prime factorization. So review this with me, please, on a separate piece of paper. We are going to review how to do the prime factorization of a number and how we're going to write it. So I'm going to do the prime factorization of 360. Now there's a lot of different ways we can start. 360 has a lot of factors, so you might choose to start the way I start, 10 times 36. That seems pretty easy to me. These are not prime numbers. I have to keep going. Perhaps you'd like to use a factor tree. Might look like that so far. I can ask myself, am I finished? Do I have all prime numbers? Nope. 5 is prime, 2 is prime, but both of these 6's can be broken down further. So I bring down what I have, and I make each of these 6's 3 times 2. Now I examine my results. I've got a 5, a 2, a 3, another 2, a 3, and a 2. I'm good to go for prime numbers, but I'm not finished yet because I need to check and make sure that when I multiply these numbers back, I really do get 360. So I'm going to do that now in my head. I'll start at this end. I'll go 2 times 3 is 6, times 2 is 12, times 3 is 36. Doubled is 72, and 72 times 5 is 360. I'm good to go. So now that I have gotten the prime numbers, the prime factors written, I need to put them in exponential form. That's very important. So you will write them generally from smallest number to biggest, 2 to the third power times 3 squared times 5 to the first. This is my prime factorization of this number. Let's review one time about how we do it if we have variables in our expression. So let me add another page, and let's do a prime factorization of 40 x cubed y. So like we did in class, we are going to do the factor tree for the 40. 4 times 10, which is 2 times 2, times 5 times 2. I've got all prime numbers. I'm going to multiply back. 2 times 2 is 4, times 5 is 20, doubled is 40. Yep, I'm good to go. So I'm going to write this lowest to highest. And all I do are bring my variables down, just like they were written. Couldn't be easier. Box it up, and you have your prime factorization for an expression that has variables in the term. So we're going to use this prime factorization a lot in section 4.2. That's why I wanted to review it. So let's get back to our notes now for 4.2. Page number 1, we have a little vocab. I've put some of it in here already. We'll talk about it as we go as well. You're taking good notes. A common factor. Well, common factors are, first of all, they're whole numbers. So we're not dealing with any decimals. We're not dealing with any negatives. So these are whole numbers that are a factor of 2 or more numbers. And the largest, the greatest of the common factors is called the GCF, or the greatest common factor. So this is the greatest of all the common factors between 2 or more numbers. Relatively prime is important. We're going to talk about it a lot. Relatively prime numbers are 2 or more numbers that have no common factor other than 1, that have 1 as their only factor in common. We'll talk about that a little bit more as we go. So we've got some examples coming up of finding the greatest common factor of 2 or more numbers or expressions, and we are going to use the method I'm going to show you in the notes. There are 2 methods in the book, and we're not using either one of them. So please, when you start your homework, you use these notes as your guideline. All of our prime GCFs, all of GCFs start with the prime factorization of all of your numbers or expressions. This is what I told you in class. If you can't get the prime factorizations correct, you're not going to get the correct GCF. So we're going to start with 12. I'm going to do his prime factorization. I'll choose 6 times 2, which is 3 times 2 times 2. I'll double check it. 2 times 2 is 4, times 3 is 12. There's my check. And I will rewrite it in exponential form. So there's the prime factorization of 12. Let's do 30. I'll start with 6 and 5. I'll make 6, 3 times 2. The 5 is prime. I bring him down. I'm going to write this smallest to largest. And I don't have to put any exponents on here because everything is to the first power. They do have exponents. It just happens to be the ghostly 1 power. Now we're going to write the GCF. We're going to make a T-chart. It's going to look like this. We're going to put the GCF over here, and later in the chapter, we're going to be doing the least common multiple, which is going to go over in the right-hand side. The GCF, you go back and you look at each one of your prime factorizations, and you find what they have in common. So I'm looking at the 2's. Well, they both have a 2, but this guy doesn't have a 2 squared. He just has a 2 to the first on his side. So they have a 2 to the first power in common, and they also have a 3 to the first power in common. This 5 that's in 30 is not in this guy, so we can't pull him over there and write him over there. Now you multiply. 2 to the first power times 3 to the first power is 6. The GCF of 12 and 30 is 6. Let's do one more together. 21 and 42. We're going to start with the prime factorization. I'm going to abbreviate it. Prime factorization of each number. 21, well, that's pretty short. 7 times 3, those are both prime. I'm going to rewrite it, smallest to biggest. 42, he's 2 times 21, or maybe you started with 6 times 7. Either way will get you the same place. 21 is 7 times 3. And now again, I have all my prime factors. I'm going to write them smallest to biggest. That makes it easier to see what they have in common. And now I'm going to go over here and I'm going to make my T-chart. Here's the GCF side. We'll leave the LCM side for later. And now I'm going to go back and I'm going to look at my 2 boxes. What do we see that they have in common? Well, they don't have a 2 in common, but they do have a 3 in common, and he's to the first power. And they have a 7 in common, also to the first power. Multiply them together, and your GCF becomes 21. Pretty easy, right? So I want you to try number 3 on your own. You can wait until the video's over if you want, or you can pause the video and do it now. But you'll be doing number 3 on your own. And we're going to skip down to number 4 because I want to talk about this idea of relatively prime. So we're going to start with the prime factorization. 24, I'll do 6 times 4, 3 times 2 times 2 times 2. Does that multiply back? 2 times 2 is 4, times 2 is 8, times 3 is 24. And I'll rewrite it. 2 cubed times 3, and I'll box it up. 45, 9 times 5, or maybe you saw 15 times 3. 9 is 3 times 3 times 5. 3 squared times 5. And I'm good to go. We're going to make our T-chart. We're going to write our GCF by looking to see what do they have in common. Well, the only thing I see that they have in common is a 3 to the first power. That's the GCF. So in answer to the question, are they relatively prime? The answer is no. Because if they were relatively prime, they would have nothing in common, and we would say their GCF is the ghostly 1. But that's not the case here. Let's see on number 5 what happens. Start with the prime factorization. That looks pretty good, but I do want to put it in order. 54, I'll do 9 times 6. 3 times 3 times 3 times 2. Do I get back to 54? Let's see. 3 times 2 is 6. 18. 18 times 3 is 54. Let's write it exponentially, and let's box it up. We'll go make our T-chart. And I go to look and see what they have in common. Well, there's not a 2 both places. There's not a 3 both places. There's not a 5 both places. There's not a 7 both places. So you might want to say they have nothing in common, but they do. They have the ghostly 1. So their GCF is 1. And yes, they are relatively prime. Look at 35 and 54. Neither one of these are prime numbers. They're composite. But together, when you look at them together, they are relatively prime because they have nothing in common except the whole number 1. Okay, we're going to talk about monomials now. We talked about monomials, the definition of a monomial in class, and now we're going to look at doing the GCF of some monomials. These are just like the other ones, except we've got some variables thrown in. The variables are the easiest part of the whole GCF process, because remember how easy they were to do the prime factorization. So let's start with the prime factorization of 20x squared. I'll do 5 times 4 times x squared, 5 times 2 times 2 times x squared, and now I'm going to write my numbers first, smallest to biggest, and variables come last. Box it up. And let's do 36x. I'll start with 6 and 6, bring down the x, 3 times 2 times 3 times 2 times x. That's 2 squared and 3 squared. And the old x comes down. Don't forget your x. That's the easiest thing to do. That's the easiest way to make a mistake, is to forget your variables. Now I'm ready to make the T-chart. I'll try to squeeze it in down here. GCF. I'm looking for the numbers I have in common. I have a 2 to the second power in both of them. That's good. We'll take him. I don't have a 5, and I don't have a 3 in both places. Now, what about my variable? I've got an x squared here, which means x and x times x, but I've just got 1x over here. So all I can write down is 1x. That's all they have in common. And now I'm going to go ahead and multiply my number out, and 2 squared is 4, so 4x is the GCF. Pretty easy, huh? Okay, I'm going to leave 7 for you. We're going to come down here and let's work 8, and then I'll leave you 9. So 32 y squared. So I see 16 times 2 times y squared, which is 8 times 2 times 2 times y squared, which is 4 times 2 times 2 times 2 times y squared. And finally, I can make the 4 2 more 2's and a y squared. Better multiply this back. 2 times 2 is 4, times 2 is 8, times 2 is 16, doubled is 32. So now I'm ready to clean it up in exponential form. We've got 2 to the 5th power y squared. Box her up. Oh, this is a shorter number. 6, I can write 6x squared y as 3 times 2 times x squared times y. I'll put it in the proper order. The 2 comes first, then the 3, then the x squared and the y. Box it up. You can see why I said the variables are the easiest. The numbers take the longest. And we'll do our t-chart. GCF. I'm looking at the numbers. What do I see in common? I see a 2 to the first power. That's it. What about the variables? This guy doesn't have any x's, so I can't write any x's down. He's got y squared, but he's only got y to the first power, so we're taking just what they have in common. His GCF is 2y. So I think you guys can finish up the next few problems. You've got 9, 10, 11. Number 12 is a word problem. It's pretty straightforward. It's just asking you to use the GCF to put together these free gift bags. So you read this, see what you can figure out, but my hint is that these 3 numbers, you're going to need the GCF to indicate how many identical bags that he can make with exactly the same amount of stuff in each bag. So if you need to watch the video again, please do that. Make sure that you come with your notes complete, and I look forward to seeing you in class. Bye-bye.